So this is not on your notes, but you can be on page 3 of your notes just to be ready for when we do new material. Yesterday we talked about segment bisectors. A segment bisector cut a line in half. How do I know the segment is cut in half? Because of the what? Yes. Yeah, the little tick marks, the congruence marks. This shows that the length of EM is equal to the length of MF. We agree? All right, so there is a segment bisector, something that cuts this segment in half. What does it look like? Looks like a ray. So when we name it, we're going to name a ray. How do we name a ray? Arrow pointing to the right. And then what would my first letter be? M and then T. Okay, so that is my segment bisector. From there, we would want to find the length of EF, like the directions say. So what is the length of EM? 6x. What is the length of MF? 2x plus 4. So then you would have an algebra problem. I always move the smaller x. Which is the smaller x? 2x. I'm going to subtract it. 6x minus 2x is 4x equals 4. Divide by 4 and x equals 1. It didn't ask for x, so I'm not going to circle it. It did ask for EF, so what can I do to find the length of EF? Plug x back in, right? 6 times 1, so what's the length of EM? And then the other half should also be 6, but you can always check. 2 times 1 is, plus 4 is. So what is the length from E to F? 12. All right, we learned that. And then we also learned how to find the midpoint. I taught you 2 ways. One way is to do it in your head, and then the second way is to do it with the formula. But in layman's terms, what are we doing when we find the midpoint? Finding the middle point, yeah. So how do I find the middle between the x's? So don't tell me the formula. How do I do it? I want to find the average, the middle between them. So how do you find the middle between the x's? Add them and then divide by 2. And then to find the middle of the y's, you add them and divide by 2. You need to remember the word average because you know how to average things, right? Today we're going to learn the distance formula and it has minus signs. So a lot of students get the midpoint formula and the distance formula mixed up. But the midpoint is literally an average. You average the x's and you average the y's. So here, sometimes, again, it's not on your notes. Sometimes, yeah, if you want to write it down, you can. Sometimes it's easier to do the in your head way, and sometimes it is easier just to do the formula. You have an odd number and an even number. There's not going to be a dead middle. Because how far apart are 5 and 6? How far apart are they, guys? On a number line. They're 11. Because think, negative 5 is how much away from 0? 5, and then to get to positive 6, you have to go 6 more. So they're 11 apart. Is there going to be a dead middle between them? No. So you want to use the formula, which looked like adding them, dividing by 2. All right, what is minus 5 plus 6? 1. And does 1 over 2 reduce? No. It does not. 7 and negative 3, how far apart are 7 and negative 3? They're 10 apart. So you can use the mental math way, which means the middle number will be 5 away from each of them. Or you can add them and divide by 2, either one. If we added them, 7 plus negative 3 divided by 2. Do I need to have a plus and a minus? No. Okay, but 7 minus 3 is? Divided by 2 is 2. So you definitely could have done that one in your head. Just might have been a little harder with the negative. This next one, we can do one of them definitely in our head. Which can we find in our head? The x, right? What's between negative 12 and 0? Negative 6. Yeah. And then we have 3 and negative 5. Again, you could just add them. What's 3 plus negative 5? Divided by 2? Negative 1. So we learned that part yesterday. Today we just learned the distance formula. Okay, distance formula. So, you have a big box on your paper, yes? This is where you're going to write in the distance formula. It starts with a radical. And it will be a large radical. All right, then you're going to have two parentheses. Give space between them. Bless you. Both of the parentheses will be squared. And then here are the signs. There's going to be a minus, a plus, and a minus. A minus, a plus, and a minus. All right, so think back. Everything in math is related to each other. So this is related to the slope formula, which was y1 minus y2. You remember it? X1 minus x2. When you get into like higher maths, they're going to show you how you get from that to this. But all that's going to happen is we're going to take the x's and subtract them, and take the y's and subtract them. I do x1 minus x2, and then y1 minus y2. Because, again, I try to do the simplest thing possible, right? We want things to be simple. We want them to be easy on our eyes. So let's notice some things. The front of the parentheses is an x1 and a y1. They come from the same coordinate point. That's how it should be. You can't mix them up. So if you pull x from the first coordinate, you can't start with y from the second coordinate. They got to be from the same. And then the same thing in the back. These two have to be from the same coordinate as well. Okay? So technically the formula looks like this with 2, 1, 2, 1. x2, y. But what is the reason? That's more complicated than it needs to be. I always do x1, x2, y1, y2. So what is the reason for this formula? Why do we have it? If you remember your homework, the classwork yesterday, looking at numbers, what was it? 4 and 5? No, 5 and 6, like this. How did we find the length of these segments? We graphed them, and then what did we do with that? You counted the boxes. You can't do that on every line. So if you want to mark it, I think, no, you don't have this. But if it is vertical or horizontal, you count the boxes. But for a diagonal line, if you have a diagonal, you have to use the distance formula. You cannot count the boxes. So if I would write that down. If you have a diagonal line, you have to use the distance formula. So I would write that down. If you have a diagonal line, you have to use the distance formula. So diagonal, distance. In 1.4, you're going to do perimeter. And at one point, you're going to do perimeter of triangles. And triangles are, one of the sides has to be diagonal. So we're going to use this again. All right, so distance formula. You have two examples. We're going to start by writing the formula. Again, it's a radical, 2 parentheses. What's happening to both parentheses? Squared. And then what are the signs? Minus, plus, minus. You can remember it. I remember it like this because it looks like a face. Minus, plus, minus. The parentheses look like eyes to me. Maybe not you. All right, and then you're going to take the first x minus the second x, and then the first y minus the second y. Which brings us to our coordinate points. Our first coordinate, we're going to call x1, y1, and our second coordinate is x2, y2. If it helps you, you can label it every time. So then we just plug in. What I always recommend is if you write it with blanks, then the negatives won't trip you up. You won't make a mistake. So if you write it again with a bunch of blanks and then just start plugging in, what is my first x that I'm going to plug in? Negative 6. And then my second x, 5. My first y, 3. And then my second y, negative 2. When I plug in that negative 2 and there's already a negative in the formula, what's going to happen here? Becomes positive. Negative, negative makes a positive. All right, so now we have to make sure we simplify correctly. You want to simplify in the parentheses first. So remember PEMDAS? You're going to use parentheses, exponents, multiple, all that stuff. So start with the parentheses. What is minus 6 minus 5? Negative 11. Everything else is still there. We haven't done anything with it. Negative 11 squared. And then what is 3 plus 2? 5. All right, so we did parentheses. Now we do exponents. What is negative 11 squared? Is it negative? It won't be. So whenever you square it, you're multiplying it times itself. A negative times a negative is going to make a positive. So it's positive 121. And then 5 squared is 25. You will want your calculator because you're going to do the radical. 121 plus 25 is 146. Your textbook rounds to the 10th. So the way to remember decimals, how many zeros does a 10 have? 1. So the 10th place is 1 decimal place. All right, so go ahead and type in, when you have a 4 function, you have to type in 146 first, and then you hit the radical. So 146, and then you hit the radical. All right, so what is the square root of 146? 12 point what? All right, we're going to round to 1 decimal place, though. So 0, 8, the 8 makes the 0. Is it going to stay or go up? Go up, so 12.1. Bless you, I think. Was there a cough? Okay, my bad. Still be blessed, you know. All right, letter B, we're going to find the distance between the points. So this is the same idea. We just have to know what the points are first. So let's start with this point on the y-axis here, okay? Every point is an x and a y. So to figure out the x, from the origin, did we go left or did we go right or we didn't go anywhere? We didn't go anywhere. So what number represents that? 0. So 0. And then we went down how many units? We went down 5, which would be a negative 5. Same idea. We want an x and a y. From the origin, for my second coordinate point, did we go to the left or to the right? To the right, how many spaces? 5, so it's a positive 5. And then we went up 1, so a positive 1. So we may differ when you label them x1, y1, x2, y2. But I read left to right because that's what we do in America, right? So I'm going to call 0 and negative 5 my first coordinate. It is not wrong if you call it the second coordinate. It does not matter. But I'm going to call it my first coordinate. And then 5, 1 will be my second coordinate. So that's how I will personally be plugging them in. It is not wrong if you had reversed it. But again, we're going to use the distance formula. I'm just going to reuse the one I wrote up here because it's still the same formula. So, here we go. What is the first x that I'm going to plug in? It is 0. So first x will be 0, and then my second x, 5. So 0 minus 5, and then my first y, negative 5, and then my second y is 1. We were a little less confident, and that's fine, or maybe you're working ahead. But you can always check, is 0, negative 5, does that come from the same coordinate? Yes. And then does 5, 1 come from the same coordinate? Yes, so we did good. All right, so now we combine like terms and all that. So in the parentheses, what is 0 minus 5? Negative 5. We can go ahead and square it. What's negative 5 squared? 25. And then minus 5 minus 1. Negative 6 squared is? And then 25 plus 36 is 61, which rounded to the nearest tenth. 7.8.